object-oriented and functional languages. So we're basically looking at the imperative. What are imperative programming languages? What are object-oriented programming languages? What are functional programming languages? What are their strengths? What are their weaknesses? So basically, when we talk about the a programming paradigm, you're actually talking about a way that we use to categorize, or in other words, to catalog the programming languages. So we are categorizing them based on their features, or maybe based on the characteristics that they have. So we categorize programming languages into several paradigms. Remember, I said the paradigm is the way we categorize a programming language based on their functions, or on their features, or their characteristics. So we have paradigms that are concerned with effects for the execution model of the language. Effects such as allowing the results, or maybe the sequence of operations that is being defined by the execution model. So we have various programming paradigms. For example, we have the imperative programming paradigm, which is also known as the procedural programming. So we use those two terms interchangeably. We use the term imperative interchangeably with the term procedural programming. Then we have object-oriented programming as another paradigm. Then we have functional programming as another paradigm. We have logical programming, and we have declarative programming. What is it? Msumbufu tu. Mwenye atakuwa ana shida. So I was saying there are various paradigms. We have the imperative paradigm, and I said the other words for the other name for imperative paradigm is procedural. Then we have the object-oriented programming paradigm. We have functional programming paradigm. We have logical programming paradigm, and we have the declarative programming. So let's begin by talking about the imperative programming. So in an imperative programming, or what we call procedural programming, here it is a paradigm that uses statements that alter a program state. So we want to achieve a certain goal. For example, in an imperative language, for example, if we look at Java, because Java is an imperative language, in other words, it is a procedural programming language. So it is a language that assumes that the computer is able to preserve through environments of variables and any changes in a computation progression. Now what I mean here is we have execution that is being done through guided series of steps, or guided sequence of steps. And in these steps, we have variables that are actually referred to, or they are altered. So in other words, a program in the procedural organization, or programming, or in the imperative programming, a program is run, or it is executed in a step-by-step manner. Is executed in a step-by-step manner. There is a sequence, a guided sequence of steps that are followed in execution. And during these executions, we have variables that are actually referred to, or we have variables that are altered. We have variables that are referred to. We have variables that are reassigned. That's what we talk about being altered. So the order of the steps in this particular paradigm is essential, or is important, because if we look at a given step, one given step might have a different consequence depending on the current values of a variable when that step is executed. Now, just a simple example: if we do a program where we want to add two numbers. So let's say we have a variable x and we have a variable y. So we want to add these two numbers. So if we say we say, or let's say maybe you want to find the average. Let's say you want to find the average. Now to find the average, you have to get the sum of this, then you divide by 2. So step 1 will be get the sum. So it will be x plus y as step 1. Step 2 would be divide the sum by 2. So it will be the sum that we'll have obtained in step 1 divide by 2. So in procedural programming, these steps are followed in that particular order. That order is very important. The reason as to why the order is very important is because when you look at the given variable at a particular step, it will have a different consequence. For example, assuming that x was 10 and y was 5. Now step 1 is giving us 15. Step 1 is giving us 15. Now step 2 is obviously giving us 15 over 2, that is giving us 7.5. Now I want you to see something. If we are going to write this same program but we change the order, in other words, we take step 1, we take step 2 and have it appear as step 1 and step 1 appear as step 2, then we're going to have something like here we have something like the sum as step 1. We have the sum, and this sum is divided by 2, and then we have step 2, and in step 2 we have x plus y. Now notice, if we print these results here using a C plus using a procedural programming language, what is going to happen here is the result of the average that we're going to get is going to be 0. Here the result is going to be 0. Here the result is going to be 7.5. Why? Because at this point here, at this step 1 here, the value of sum is actually 0. The value of sum is actually 0. Why? Because we did not have this operation being done. We did not have this operation being done. So it is essential, it is important for us to realize that the steps or the order of steps that are being followed in this particular paradigm is very important, because at a given step a variable might have different consequences, of course, depending on the current values that is actually holding. So it is a paradigm that is making an assumption that the computer is able to maintain through environments of variables and any changes in a computation process. So we have guided steps that are followed, and these steps are supposed to this order of the steps are supposed to be referred to. Okay, that is if you look at examples of the imperative languages, so we have popular programming languages that are imperative more often than they are maybe in the other paradigms. We have two reasons why imperative languages are popular. Two reasons why imperative languages are popular, and the first one is that the imperative languages are actually closely to the actual machine itself. In other words, they are closely to machine language. I remember saying previously that computers do not understand natural language. Computers understand machine language. Machine language is a language that is made of the binary number system, that is zeros and ones. So most of these imperative languages are more closely, or it is a paradigm that is actually more closely or resembles the actual machine. So that means the programmer here is much closer to the machine. Reason number 2 is that it is a paradigm that is one of the, or it is the most efficient. It is the most efficient. Why is it most efficient? Because it is close to the machine. It is close to machine language. So now it took up the widespread use until now. We have the advantages of imperative programming languages, and the first one is efficiency. It is efficient, and the reason as to why we say it is efficient is because it is a paradigm that is closer to the machine, so to the machine language, so hence more efficient. It is also advantageous that this paradigm is closer to the computer, or it is closer to the machine language. It is advantageous that it is a popular programming language. Of course, if you are coding using a popular programming language, then what basically means is you can get enough resources online. You can get enough people to actually help you when you are stuck with a problem, because there are so many other people that are coding in that same language. So it is advantageous when you are actually working with a programming language that is popular. It means you have many other reference materials online, and you have many other people that you can collaborate with. Now, advantage number 4 is that it is familiar. So it is a language that is it is a paradigm that is familiar to many people. So there are a number of disadvantages also for the imperative programming languages, and the first one is that it may have complex semantics. The syntax of these particular programming languages might be complex because we have what we call referential transparency. So it has complex semantics. Number 2, debugging is harder debugging because we have side effects. Harder debugging due to side effects. Number 3, there is limitation in abstraction. If you compare this particular paradigm with other paradigms, then this one has limitations in abstraction. Number 4, order is very important. That is a disadvantage. Order is very important because if we are sticking to order, that particular approach might not be suitable for some problems that we need to solve, because they don't want us to stick in a particular order. So that is a disadvantage. So now on to the object-oriented programming paradigm. That was all about the imperative. Now, in the object-oriented programming paradigm, it is a paradigm that views it views the real world objects as some separate entities. So we are viewing the real world objects as separate entities that have their own states, and these states can only be modified by procedures that are built in, and the procedures that are used to modify these states are called methods. So we have objects that are actually operating independently. They are put into modules, and those modules contain both local environments and methods. So the communication that is supposed to be done within an object is supposed to be done by message passing. So what you need to understand is the actual the actual objects that we have are normally categorized into classes. Okay. Now, if you categorize them into classes, then from these classes we are able to they are able to inherit methods and other variables. So if we have inheritance, then it means we have benefits of this paradigm. Two of them, which is actually one, we have reusability of code, and number 2, we have extensibility. So if we look at the object oriented the paradigm, we said first of all we are viewing the real world objects as separate entities that has methods that can be modified. So if we also said that objects are organized into classes, and these objects can inherit properties and even variables from the other classes. So to get a better understanding of that, let's look at the features and benefits of the object-oriented programming. So when we have a new class, one of the benefits, or one of the feature that is beneficial, is that we can create we can create a subclass from another class. We can create a subclass, or maybe we call it a derived class. So we can create a derived class or a subclass from another class. The class that we create that class from, we call it the base class or the superclass. Now this is a mechanism that we call inheritance. I'm just going to use a simple example. You are a product of your father and your mother, but let's forget about the mother for now. You are a product of your father. Now since you are a product of your father, there might be one or two features of your father that look similar in you. You might have one or two features in you that look like your father, but you don't look exactly like your father. What does it mean? You are derived from the genes of your father. You are a subclass, and your father is a superclass or is a base class. So when we group objects into classes, then it means we can create other classes from those classes. You can create a subclass from the main class, and the subclass is able to inherit the features of that superclass, including the variables of that class, just like you are able to inherit some features from your father. You have other additional features that are not like your father's features, but you have some features that uh, look exactly as your father's features. So that is it. So we can create a subclass from another class from us, or a superclass. Now the class from which a subclass is created is known as a superclass or a base class. Now the class that is created from a superclass or a base class is known as derived class or a subclass. It's very important. Now the concept or the process or the mechanism by which a subclass is created from a superclass is known as inheritance. The mechanism by which a subclass is created from a superclass is known as inheritance. The same way, you inherited the features of your father. So maybe your nose is looking like your father. You inherited the features of your father. You have a round face like your father. You inherited the feature of your father. You are a subclass of your father. Your father is the superclass in this case. So it's just the same thing. We obtain that through a mechanism known as inheritance. Through a mechanism known as inheritance. So it's very important for us to know that the the subclass or the derived class is able to inherit all the features of that base class or the superclass. It is possible for you to inherit all the features of your father, and you look exactly as your father. Okay. But this is not always the same. It's not always the case. So you are able to inherit the subclass is able to inherit all the features of the superclass. It will be able to inherit its structure. It will be able to inherit its behavior. But in addition to inheriting whatever is coming from that superclass, the subclass can also have some additional states. For example, it can have some additional variables. It can have some additional behavior that the superclass does not have. Okay. So I hope that is clear. Now the ability to actually use inheritance in the single most distinguishing feature is actually one of the, or not one of the, it is the most distinguishing feature. It is the feature that sets object-oriented programming apart from all the other paradigms. The ability to use inheritance, the ability that objects can inherit or classes can inherit. So inheritance, in other words, is the feature that gives object-oriented its chief benefit, its main benefit over other programming paradigms. So somebody knows, if I use object-oriented programming paradigm, I'll definitely be able to use inheritance. So it makes coding relatively easy. It brings in code reusability. Then it is also possible to extend some code, to do some extension without changing the source code that you actually have. So if we look at an example here, the class car. So you have the class, okay, the class vehicle. It has an object car, and the object has methods. For example, refuel, get fuel, set speed, get speed, drive. Those are methods. Then you have attributes, and the attributes could be fuel, for instance, and we have the maximum speed as an attribute. So all the other vehicles that fall in the class vehicle are going to have these features. They're going to have these features. For example, if you bring in here okay, this is a car. Then if you bring in here maybe a van, you bring in a van. Now when you bring in a van, you see it has the same features, but the van has extra features that the car does not have. You bring in here a truck. The truck has the same features that the car, but it has more features that maybe the car does not have. So we are creating some real-time objects when we put them in classes. Now the next paradigm that we need to talk about is the functional programming paradigm. Now for functional programming paradigm, we view all the sub programs as functions in the mathematical sense, or in other words, what is a function? A function is a group of code that executes that actually performs a specific task. A group of code that receives input, works on the input, and gives out an output in the process of solving a particular problem. So the output of a function, or the solution of a function, is based on the input that you actually give it. Okay, not on the time, at which a function is called. It is based on the input that is supplied to that particular function. So for demonstration purposes in this course, we are going to use C++. We're going to use C++ programming language for demonstration purposes. And for us to be able to code in C++, we need to install, we will install dev C++. To do that, you just go to your browser and you type there dev C++. This is the software, the compiler that we're going to use, or the code editor that we're going to use to actually run C++ code. As I said, I want you to get the one that comes from SourceForge. Download the one that comes from SourceForge. So I'm going to click on this link here, and then I'm going to download. So our download will start shortly. Let's allow it some time. It is a very small file, something like 48.1 MBs. It is not supposed to take very long unless you're using a machine that is very slow. I want us to install this software because it is the one that we are going to use to demonstrate. It is the one that you're going to use to demonstrate, and I want to demonstrate the functional. I'll talk about functions later, but I just want to show you how the functional programming language programming paradigm works. So once your file is downloaded, just a second for mine to finish. Okay, you can open it, you access it here. Of course, mine appears in the downloads, so you double click on it to install it. We need to say yes. So please wait while setup is loading. We need to give it some little time. You should be doing the same. You should be downloading dev C++, because we are going to code in C++. I'll be explaining concepts with example code. So because the way ABMA handles questions, at times we have, or most of the times, especially in the unit of programming, you have practical approach to questions, write a program, or maybe show a function, implement this. So we need to do some practical part of it. I have chosen C++, and the reason as to why I have chosen C++ is because when I check, most of the questions in computer programming are actually asking for C++ programming languages. So if a question requires you to write code, most of the times they are asking you to write in C++. That does not mean ABMA cannot ask you to write in any other programming language. They can ask you to write in any other programming language, but most of the questions that I see, they require answers in C++, and that is one of the reasons I settled for C++ for this lesson. Are you talking?
Sure.
Yes.
Sioni hiyo. Naongea. Unasikii? Sioni hiyo yenye imetoka kwa source whatever.
It is there, just be careful.
Nimeandika tu C++.
I said rewrite dev C++. DEV C++. So let's give it some little time. Some little time. Be patient a little bit. Yeah, it's almost done. It's almost done. Yes, so we can hit on finish. Can hit on finish. I'm working on a desktop that has really slow speed. Okay, so mine is installed. It's here. I'm going to start it up.
Ngoja kiasi cha yangu nimesha download.
So just say next and say okay, so that we have it launched. So we have our program here ready. I'm not teaching you programming in C++ right now. I'm just demonstrating this. I'll go into the details of C++. I'm going to actually teach you how to program in C++. But now I'm just trying to explain this concept here, functional programming. I'm trying to explain that concept. So in case you don't understand the lines of code that I'm gonna write, do not worry. We're gonna talk about that much later. So you've got to relax. Okay, so we said the functional programming paradigm is actually a paradigm that splits the code or puts the code into or looks at the sub-programs as functions, and it looks at the sub-programs as functions in a mathematical sense. Now a function takes in arguments and then returns a single solution. I'm going to show you what that means. So I'm going to click on file in my program, new file, new project. I'm going to select empty, and I make sure here C++ is actually chosen. I'm going to say okay. Just want to show you functions. That is project 1. Let me just call it functions. Then I'm going to click save. So you have this code editor place that you can actually write. So I'm going to write a simple C++ program that implements a function. So I'm going to say hash include iostream. Don't worry about what I'm typing. I'm going to really talk about it much later. iostream. Then going to say using namespace std, a semicolon. Then I want to declare a function. So I want to write a function that will add two numbers. So I'm going to say int add two numbers. The function name for me is add two numbers. I'm going to call it add two numbers. And this function, we said the function takes in parameters, so it takes in input. So we're going to give it two numbers. So all the numbers will be of the type integer. Don't worry about data type. I'm going to talk about it in the next class. So it's going to take int a as the first parameter, then int b will be the second parameter. So it is going to take those two parameters. Then this function should do something, and I want it to return the result that it should return should be something like a plus b, because we want it to return the sum of two numbers. So should return a plus b. So this is a function. It does something. It is actually taking in, don't worry about I said do not worry about understanding this code. I'm going to teach you C++. So it is taking in two numbers, which are parameters. It is taking in the a, it is taking in the b. Then it works on those two integer variables here. It takes that integer, that a plus that b, and then it returns that to the console. So it should print that to the console. That is what the function does. Now, after we have finished actually declaring our function, we need to write our program now. Int main. So we are going to give this program two numbers. Int a is equal to 100. You give it int b is equal to 200. Yeah. Then we are going to call that function console out. The sum is, say the sum is, then here just call that function add two numbers, add two numbers. We call that function add two numbers. Okay. Then we return 0. So if we compile and run this code, let's just see. Okay, there's an error here. Two numbers into a. So a comma b. So you see our function here is showing the answer. The sum is 300. So this is our function here, and then we called it the function here. So in functional programming paradigm, it actually views all the subprograms as functions, and these functions have input. I've shown you what the input are here, and the input that we are supplying here is this a, the parameters, a and b. We call them function parameters. Then it has a method. This is the method. It has a method, this one. It is taking a plus b, then it is returning it. So we are calling the function here. Now notice, if you want to actually work on different numbers, we can just come and call, let's call this function again. Let me copy it, and we call it here. But this time we just give it numbers instead of a comma b, this other one. So let me just give it 1000, and let me just give this one 500, and then we compile and run. Just want to see something. So you see it is showing the sum is 300, the sum is 1500. So the first sum is this one shows 300, then we have this one shows 1500. Now we have our function here, and we are calling this function. So that is a simple demonstration. So the functional programming paradigm is looking at those sub-programs, takes them as functions in a mathematical sense. They are going to take in arguments, then they return a single solution. They are going to take in arguments. Of course, we have the argument A, argument B, then they return a single solution. The solution is this one here. It was returning to us 300. Then they return a single solution. So it's more important to understand. Now, what I was trying to say is that the solution that these functions give, or the output of these functions, are entirely based on what type of input you give them, and not actually what time that function was called. So if you come here, for instance, and change in this line, we changed the input. Let's just remove this one. Here we changed the input to 1500. 1000 for A. We can even remove these ones. We don't need these lines here. So if we change the input to 1500, then we run, I want you to realize that now the output changes. It shows us 1500. The output changes based on what input we supplied here. It is based on what input we supplied here, not based on what time did we call that function. Now, for instance, we can call this function in any place that we want to call it. For instance, I can actually remove this one here, or maybe add some other code here. Let me just print out this message. Log to the console out, and just wanna say something like the sum of two numbers is printed next. So that is just a line, and I just put that, or rather, let me just put this and say, and I'll put that. Now, if I run this again, I want you to notice something. If I run this, you see the sum of two numbers is printed next. The sum is 1500. So I have called this function here. I am illustrating the point that the output is determined by the input, regardless of the time that function is called. So what if we move this function call into this place immediately after the curly braces there, and then we run that? Let's see what happens. Is it going to affect the output? No. The sum is 1500 shillings. The sum is 1500. So the output is not affected by the time when that function is called. It is only affected by the input that we give to the functions. So examples of languages that are created based on the functional paradigm, we have languages that these actually languages that are they permit functional solutions to problems by allowing the programmer to actually to treat functions as the first class objects. So it allows the programmers to treat functions as the first class objects. So we can treat them as data. We can assume that we have the value of what they return, and so we can pass that value. The value that function returns can be passed to another function as an argument. It can also be returned as an argument. Now, if you look at this function, this function is returning a plus b, is returning that value. So we can still pass this value to another function. If we declare another function, we can pass this value to another function, or we can take in a value into this function from another function. That is what I'm really trying to talk about here. Now, the advantages of functional programming: one, there is high level of abstraction. There's high level of abstraction. So when we use functions, we are overwhelming so many of the details of programming. So we are actually removing the opportunity of many classes of errors in our code. Number two, there is efficiency. There's deficiency. Okay, we have deficiency of dependency on assignment operations. We are not depending on assignment operations in this case, so that allows our programs to be valued in many different orders. So we have the evaluation order that is actually independent and is going to make that function oriented language worthy for applications in parallel computers. Number 3, the lack of assignment operations makes the function-oriented programs much more responsive to mathematical proof and analysis than the other authoritative programs. Now, because we have the functional programs that own referential transparency. The disadvantages includes: 1, they are less efficient. Number 2, if you have problems that are concerning many variables or a lot of some sequential activities that are supposed to take place, they are sometimes easier to handle. They are not easier to handle with. They are actually easier to handle with object-oriented programming. If you have problems that have many variables, or they have a lot of sequential activities, they are not really easy to handle with functional programming. They are easier to handle with object-oriented programming. So we have logical programming also as a paradigm. So logical programming is a paradigm that is going to take in a declarative method to problem solving. So we have various logical declarations about a particular solutions that are made. Then when we make these logical declarations, we are forming known facts. Then we are making queries. Okay. So the role of the computer becomes preserving data and the logical assumption. So we have a logical program being divided into 3 sections. 1, we have the set of definitions that are going to define the problem. Number 2, we have the reports of the relevant facts. Then number 3, we have the declaration of aims in the form of a request or maybe in any other reducible answer to the query that is being returned. So the definitions and declarations that we make here are built from relations. So advantages of logical programming: 1, the system solves the problems, thus we have programming steps that are kept to a minimum. We have less programming steps here because the system is actually solving the problem on its own. Number 2, demonstrating the rationality of a given program is quite easy. Demonstrating the rationality of a given program is quite easy. So I want us to move to factors affecting the suitability of a language for a particular task. Now, if you want to develop different types of applications, we have different types of programming languages that are actually available for use. Now, for you to be able to develop a software for maybe a specific application, you need to be very keen when you're choosing the language that you want to use to make sure that you have a program that is easy to develop and is efficient in a given period of time. So we have certain factors that must be considered by a programmer while the programmer is choosing a programming language for maybe a software development. So we have factors like the purpose. Factor number 1 is the purpose. So the purpose is going to specify the objective of the programming language. Okay? What is the objective for which a program is being developed? You are developing a program. What is the objective of that program? If maybe an application you want to develop is a commercial application, you need to go for some programming languages that are business oriented. You want to develop a commercial application, go for languages that are business oriented. For example, we have the COBOL that is actually preferred when it comes to commercial applications. If you want to create some scientific applications, for example, then you need to go to scientific oriented languages. For example, we have Fortran that is actually known for scientific purposes. You want to create a program that is related to artificial intelligence, you need to actually look at a program that at a language that can develop efficient programs that are related to artificial intelligence. So in other words, you need to be sure, you need to know the objective of the application you are developing first, and then you use that objective to select which actually is the most preferred programming language to use to develop that system. Number 2, programmer's experience is the second factor. Programmer's experience. At times you have so many, or you have more than one more than one programming languages that are actually present for developing that same application that you want to develop. So you as a programmer, you must choose a language that you are comfortable in its level. The level you are in that language, you are actually comfortable. So you should go for a language that you have more experience. Okay? Go for a language that you have more experience. If you are supposed to develop a software and it can be developed using C++, at the same time that same software can be developed using Java, and you are at free, you are given a free will to choose which language to use. If you are competent, you are more competent in Java than C++, then you should need to settle for Java. If you are more competent in C++ than you are in Java, then you need to settle for C++. Choose a language that you are comfortable to work with or you have more experience with. Number 3, the ease of development and maintenance. As a programmer, any program that you actually develop, it will need to be maintained. So use a language that you feel comfortable with. Okay, and if it is about maintenance and development, you realize that the object-oriented programming languages are more preferred over the procedural programming languages. Now the reason is so simple that the code that is developed in the object-oriented programming languages can be reused and can be maintained with great ease. So select a programming language that is easy to develop, that is easy to also maintain, and that would take you to the choice of object-oriented programming languages, because there is reusability in object-oriented programming languages. Number 4, look at the suitability of a programming language. Check if that programming language is suitable for the scenario that you have at hand. Now, how do you check for suitability? There are two things that you need to check in the suitability. There are two things that you need to check in the area of suitability. And the first thing is that you have platforms that you want that application to work in. So check which programming language will actually work in all the platforms that you require the application to work in. Which programming language will able to work with all the platforms that you require the application to work in. That is the concept of suitability. Number 2, you need to look at which language has the features you are looking at. Features like it will allow multiple users to use that program at the same time. The features that are required by your stakeholders. Which language can offer those features? So when you are able to answer those two questions, then you have sorted the issue of suitability of a programming language and you are good to go. Number 5, factor number 5 is performance and efficiency. Performance and efficiency. Now these are two very important factors that need to be considered before you actually start choosing any programming language for any development process. So choose a language that programs can be developed and executed rapidly. Choose a language that development and execution is going to happen rapidly. So in addition to that, make sure the language requires some less amount of memory for the storage of that program. So the development and execution should be rapidly. Number 2, the programs should require less memory for storage, less amount memory for storage. Number 6, look at the availability of integrated development environment. Okay, and here you need to go for the language that is actually well supported. There are debugging tools available. There are compilation tools available. It has powerful IDEs. When you have a powerful IDE, then you are increasing the productivity. You are increasing your productivity as a programmer. Number 7, we have error checking and diagnosis. Error checking and diagnosis. Under error checking and diagnosis, there are two factors that are also important. So you as a programmer, you must choose a programming language that has efficient error handling features. If you look at Java, for example, it is very efficient when it comes to error handling mechanisms. It has what we call the catch block, the try catch block. Okay, so we normally use the try catch block in Java to make sure we handle the unexpected errors that might occur during the execution of our programs. So error checking and diagnosis is very important. Make sure you look into it if you want to develop quality and error-free programs. So look for a programming language that has efficient and robust error detection and it also has correction mechanisms to make sure that you have quality programs. Number 8, look at the organizational policy. We have other organizations that choose programming languages for themselves, and they say that all the softwares that we actually want should be written in Java. That is a policy. So make sure you are sticking to that policy. If the company requires using Java, you stick to Java. If the company requires using C++, you stick to C++. Okay, so we might have policies that are also stating they are stating the type of a programming language that you're supposed to use. So you must choose a language that is actually meeting um, the policy of that particular organization. Number 9 is suitability of features and tools. It's very important to look at the suitability of the features and tools of a programming language, because we have a wide range of programming languages that are available. We also have so many different features that are actually specific to some certain languages. So the company will be required, or the programmer will be required, to make an analysis of the features to just make sure, or to be sure if those features can be used to meet what the system is required of, or they cannot. So they need to consider if the language only works with maybe some specific hardware or some specific software. Number 10, we have availability of trained staff. So as you're choosing a language, maybe for an organization, you need to look at your staff, the trained staff that you have. You want to code in Java. Ask yourself, do we have staff that are actually trained in Java, or do we have staff that are competent in Java? If you have, then you would settle for it. If you do not have, you would need to choose a language in which your staff are actually trained in. Number 11 is reliability. We have languages that have features that allow you as a programmer to actually create some reliable program. Now this can be because of the merging that we can have between programming paradigms. One programming language can have a mix, can combine different features from other programming paradigms. So it's very important to make sure that you choose the one that is more reliable. We have development and maintenance costs. So you choose a language that will make it easy in terms of cost when it comes to development. It will make it easy in terms of cost when it comes to maintenance. So consider how much the software licenses are required, for how long are you going to use those softwares, etc, etc, etc. We have expandability. Choose a language, choose a programming language that is easily expandable, that is going to allow programmers to create maybe a program that can sustain multiple users without having the program crashing. We have other programming languages that are more expandable than others. They have features that can support larger systems that may be programmed. Popularity. It's important you choose a language that is popular. Why? Because if you are using a language that is popular, you are more likely to find people you can work with, you can collaborate with. You are more likely to find reference materials that can actually help you. Okay. At times you might find that the most popular programming languages are not a good match for you. That will be too bad. But if the popular programming languages are good match for you, then you would settle for that, because you can get some help. Then we look at the availability of libraries. Okay, are there enough libraries that can actually help you in solving your problem? Look at the efficiency of the languages. Okay, look at the efficiency of compilers and the interpreters of the languages before you actually settle for them, and before you decide to choose them and use them. Yeah, so that was real quick. That's it for today. We are going to start outcome 2 from tomorrow. We are going to apply some common data types, data structure, algorithms to problem solving. So we're going to talk about the common primitive data types, and we go on and on. One thing I want you to realize, I want you to note, is we will be using dev C++ so much to run our code, to illustrate concepts. For example, in this lesson tomorrow, we are going to really use that software. So make sure you have the software installed ready and it's really working for us to be able to continue.